All right, we're still looking at the applications of Newton's second law of motion, and I've been talking about the applications of this Newton's law of motion. Now we're applying it to the connected particles. You can see three masses connected together: mass m1, m2, and m3. And this diagram appears somehow. If you're not careful, you'll be scared. But how do we do the analysis? We have to resolve for the acceleration and the tension in the string. A good thing about this diagram is that all the masses will move with a common acceleration, with the same acceleration, and then a string connects M1 to M2, and a different string connects M2 to M3. And this string, passes through the groove of a very small pulley. We are going to ignore the effect of frictional forces between the string and the groove of this pulley. Okay, so very quickly, we see that the tension here is the same. That is, M1 and M2 pull each other with tension T1, and T2 and T3 is the tension in this other string, which is equal because this mass M2 pulls M3 with T2, and M3 equally pulls M2 with the same tension T2. So I'm going to draw a free body diagram for each of these masses to enable me proceed with the solution of this equation. Solution of this problem. So first of all, let me start with mass m1 and then show all the forces acting on mass m1. Mass m1 rests on the table, and then let's say the first one is the weight of mass m1 given by m1g, which is the weight of the body, and we have the normal force, that is n. I call that n1. Okay, so I may split this into two so that I have here tension T1. That's the force exerted by m2 to pull this particular one forward. Okay, so I want to look at a case where frictional force doesn't act. The surface is smooth. We're talking about number one, smooth surface. The surface is smooth surface. That is, there's no frictional force acting between the table surface and the block. Okay, so let's see the second mass M2. The second mass M2 is this. This is still T1. Okay, and then this is T2 acting this way. And they also have the weight of M2, that is M2G, acting vertically downwards, and a normal force. I'll call this one M2. Now, these two forces will not be the same. That is, N1, the normal force from this surface, acting on M1, will not be the same thing as N2 because you can see that since these two surfaces, or since these two blocks are in equilibrium, it means that M2G is equal to N2. And M1G is equal to N1. And since M1 and M2 are different, so it means that N1 will be different from M2. So the unit way this and this are equal is when the two masses have the same value. Okay, having said that, we make progress. Now the third one is M3. M3 is acting this way. M3 is not resting on any surface, it is just floating. It is left hanging in space. So the weight of this is m3g, and then the tension T2 also pulls upward in this direction. Okay, I can quickly draw my coordinates as is if I wish to, x and y coordinate as is, so that if I apply to this block M1 and M2, so the force acting in the direction of the positive x-axis is taken as positive. Any force acting to the left, to the negative direction of x, will be taken as negative. Okay, I may give this force positive, that is acting vertically upward, and if force acting downwards will be given a negative sign. Okay, we are considering the case where the surface is smooth, there's no frictional force, which means we are going to apply Newton's second law of motion to these blocks of the three masses. Okay, now for the first mass, M1, I have resolving horizontally, I'm going to have T1 is equal to M1A. That is to say, since no frictional force opposes the motion of block M1, okay, I call that equation 1. And then resolving horizontally for mass M2, I have T2, since it acts in the direction of the positive x-axis, that's positive, minus T1 equals M2A, according to Newton's second law of motion. And then for this, I'll give this direction of motion because M3 moves in this direction of motion. So that my M3 is now positive, M3G is positive, T2 be negative. So that gives me M3G minus minus T2 gives me M3A, equation 3. Okay, I have these three equations. I have to add them together. Okay, I add. Now, if I want to add, that's a trick I'm going to apply. I don't need to do substitution. Another method of solving this, you just make substitution. But you can add. If you add, this T1 is positive, add it to minus T1, that will cancel out. T2 is positive, add it to negative T2, it goes away. So that on the left-hand side of the equation, what is left is this M3G, which is equal to, on the right-hand side, I have M1A plus M2A plus M3A. So my A is common into M1, okay, plus M2 plus M3. That is equal to M3G. Okay, so we can now write down the expression for our common acceleration, which gives you M3G over M1 plus M2 plus M3. Okay, already we are given the values of these masses. The question says if M1 is 3 kg, M2 is 4 and M3 is 5. So what is the acceleration and what's the tension in each string? So the common acceleration is now 5 times 10 because M3 is 5 over 3 plus 4 plus 5. That gives me 50 over, this is 12. Okay, so that gives me 4.2 meters per second approximately. So that gives the common acceleration of the three blocks, meaning that M1 moves to the right with an acceleration of 4.2, likewise M2, and then M3 moves vertically downwards with the same common acceleration of 4.2 meters per second squared. Now, how do we find the tension in each string? Okay, we can come to the first equation of motion. T1 was equal to M1A. I have my M1 as 3, my A is 4.2. So the tension in the first string, or the string that connects M1 and M2, is 3 times 4.2, which gives me 12.6 Newton. Okay, I can also find the tension in the second string, that is T2. I can use equation 2 to achieve that. Alright, from equation 2, I have T2 minus T1 equals M2A. Okay, my T2 is minus T1 is 12.6 equals, this is 4. That was my T2 times 4.2. That gives me T2 is equal to, when I collect like terms now, or this multiplied by gives me 16.8 first of all. Bring this to this side gives me plus 12.6. So that my T2 now, that's the tension in the second string, is now given by the sum of this. That gives me, this is 4, this is 8, that is 9, this is 2, that gives me 29.4 Newton. Okay, so that's how to resolve this case when there is no frictional force acting, the plane is smooth. I've seen the equation, the formula for calculating their common acceleration. Okay, and also how to also calculate the tension in the string. Okay, let's see the case where the plane surface, the tabletop, is rough. Now, to case 2, frictional force exists. Frictional force exists, between blocks M1 and M2 and the table surface. Frictional force. Now, first of all, I'm going to look for or derive an expression, an equation for the static frictional force, static friction. We call that there are two types of friction. I've been saying that in all my classes, we're talking about frictional force, that there are two types of them. The static is that maximum force that must be overcome before a body can start moving for the first time. In fact, the static frictional force is also called the staying force. That's the force that keeps a body on a particular surface so that the body does not slide through the surface. When that force is overcome, that body cannot start sliding through that surface. Okay, for static friction, we also need to write the expression for the coefficient of static frictional force and then use that to, calculate the common acceleration and then the tension in each string. Okay, so I come back to this equation. All right, for the first block, M1, I have this is on the surface. I'll call this my Fx. Fx is static frictional force acting opposing the motion because M1 tends to move in this direction. So frictional force quickly comes in to oppose the direction of M1. And in this case, my apply resolving along horizontally, that is applying to second law of motion, I have T1 minus the static frictional force Fs is equal to M1A for Newton's second law of motion. I can call this equation 1. That's for block M1. And again, Fs is defined as mu s times normal force N1. I've already told you that N1 here. Why am I using N1? Because as long as M1 and M2 are not the same, the normal force no, N1, M2 will not be the same. All right. So, and this my normal force is equal to the weight of block M1, which is given by M1G. All right. So that's it, because for this block to rest in this case horizontally, to balance horizontally, resolving for the upward forces, it means the force acting downward, M2G must equal N2. That is normal force. And for this to be at rest in equilibrium, that means that the normal force N1 must be equal to what? M1G. So making substitution here, I have Fs equals mu s times M1G. Okay, that is it. So I can make substitution here if I wish to. So that I can now write expression for the acceleration if I'm given the coefficient of static friction. So I have T1 minus mu s M1G is equal to M1A. I can call this equation 1 also. Now for the second block, M2, we have T2 acting this way. Also have T1 acting this way, the same as this because of Newton's third law of motion. They pull each other with the same force. Then I have my M2G, the weight of this block M2, the normal force, I call that M2. So applying Newton's the frictional force also act Fs, opposes motion in this direction. Okay. So for block M2, I'm going to have T2, which is acting in the direction of the positive x-axis, minus T1 minus the static frictional force Fs is equal to M2A for Newton's second law of motion. That's equation 2. All right. So for the third block, M3 is directed this way. So its weight is M3G. You have the tension T2 opposing the motion of the block M3. Okay, applying it in this one, frictional force doesn't affect it because it's not resting on any surface. It just left hanging in space, suspended in space. So we have M3G minus T2 is equal to M3A. Now, we're talking about static frictional force. And this static frictional force is just that force that must be overcome before the blocks M1 and M2 will just jerk forward, including M3. Okay, so in that case, the blocks are yet to start moving. They are just about to start their motion or to be set into motion. It means their common acceleration in that case is 0. So all these terms at the right hand side all go to 0, meaning that I'm going to rewrite the equation T1 is now equal to mu s M1G. Okay, and then T2 will be equal to what? T1 plus my Fs here is now, we're going to write it as Fs, where Fs for the second block, Fs for the second block is mu s M2G. That is to say Fs was equal to mu s times normal force M2, and N2 rather is M2G. So I have this. So if I replace that, substitute that, I have T1 plus mu s M2G. Okay, and then my force M3G minus T2 equals 0 from equation 3. This was equation 2. I just modify that equation 2. Okay, so I have back my equation 1. This is my modified equation 1, modified equation 2, and then equation 3. So what do I do here? Do I add them together so that I can find, or I can rewrite the three equations again, these three equations. That's T1 minus mu s M1G equals 0. I've already said the acceleration in the three equations will all be equal to 0. So I have T2 for the second equation minus T1 minus my Fs for the second equation is this, which is also this for the second equation. It gives me mu s M2G is equal to 0. Okay. Then the third equation is M3G minus T2 is equal to 0. So I can bring out the three equations like this again. That is these three equations. I'm recopying them. Equation 1, equation 2, equation 3. Recall that this, what is that again? Recall that this Fx is the static frictional force between block M2 and the table surface, and is given by mu s M2g, that is normal force acting from the surface where M2 is placed. So I'm going to have replaced this Fs with this, which gives me this. Okay, I want to add these three equations as I did earlier. Adding the three equations, I have MT1 and this T1 will cross out, and then plus T2 minus T2 gone. Alright, so on the left hand side here, okay, let me write them. I now have M3G minus mu S M1G minus mu S M2G is equal to 0. Okay, G is common. Let's cancel out all the G. So I have M3, bring the others to the other side, gives me mu S M1 plus mu S M2. I'm sure you know what mu S is. That is the coefficient of static friction. Factoring that out, I have M1 plus M2 is equal to M3. So that my coefficient of static friction is M3 over the sum M1 plus M2. Okay, let's come back to what was given at first. Given that M1 is 3 kg, M2 is 4 kg, M3 is 5 kg. Can we find the common acceleration? But before, they will need to have the coefficient of static friction, F mu s, which is given as 5 over 3 plus 4. That gives me 5 over 9. Sorry, 5 over 7. Okay, when I divide 5 by 7, what do I have as my answer? If I divide 5 by 7, I have 0.7 as the coefficient of static frictional force. Okay, I've got that now. Okay, so in this case, the blocks did not accelerate, and this gives the coefficient of static frictional force. Okay, so, and if the blocks eventually start moving, then the frictional force acting between the surfaces, that is surface of block M1 and M2, will be less than the static frictional force, because kinetic frictional force is always less than static frictional force. Okay, in that case, we can write that we have this very fast. Let's just look at this quickly. Okay, let's say you have this again. This is my M1, M2, and I have this M3, M3. So the frictional force Fk, if this block accelerates eventually in this direction, this one accelerates in this direction. If this block accelerates in this direction, it means that for the first block, I have T1 acts here, minus Fk is equal to M1A. And then T2, because tension here is T2 minus T1 minus Fk, because frictional force equally acts between these surfaces, is equal to M2A. And then M3G, that is the weight of block M3, minus T2, which also acts here, minus T2 is equal to M3A. Okay, so I must be given this frictional force, or the coefficient of kinetic frictional force, to even find the acceleration of the block. So adding all together again, I have this one gone, this gone. So I'm going to have M3G minus Fk minus Fk. Okay, maybe I should call this Fk1, Fk2, because the frictional force will be different for the two blocks. My Fk1 is mu, let me call that mu K1 or mu1 times M1G, because the frictional force has been defined as the coefficient of static friction multiplied by the weight of the body. My Fk2 will be mu2 multiplied by M2G. Okay, because now mu1 and mu2 will be the same because it's the same surface, the same table, but the difference will be their masses. For this one now, m1 is different from m2. Alright, so that gives me equal to, I'll add up all these, that gives me m1 plus m2 plus m3. I factor out my a times acceleration a. Okay, so that what do I do next? I have my m3g minus, what is this again? This is my mu1 m1g, that is my fk1, fk2 minus mu2 m2g is equal to my acceleration a into m1 plus m2 plus m3. Okay, I hope this thing is not, I'm not clustering things together. Hope I'm not jam packing things together. And we are fully following the analysis. Okay, so what we do here, I've seen a lot of variables, a lot of letters, and I'm sure this will not bore you. Just about trying to do the analysis for this, to arrive at, maybe I can decide to find my coefficient of kinetic frictional force if I'm given the acceleration, or if I'm given this and this and the masses too, I can find the accelerations, whichever. So this equation can be used in any way. Either given acceleration and the masses, you can find the coefficient of kinetic friction, or given the coefficient of kinetic friction, you can find the acceleration of the body. Okay, let me first of all start by finding the acceleration. In this case, let's assume I'm given this and this. So recall that m1, and I told you earlier that this one is the same. That is mu1 is the same as mu2. I can call that mu1 equal, so the same table surface equal to mu, which is coefficient of kinetic friction, mu k is the same. So I have m3g minus mu k m1g minus mu k m2g is equal to a into m1 plus m2 plus m3. Okay, and if I'm to find the coefficient of kinetic friction, I have to say that this is m3g minus mu k, I factor that out, into m1g plus m2g is equal to a into m1 plus m2 plus m3. Then I can now decide to find the unknown parameters. Okay, I'd like to stop here and continue from here depending on the parameters given to you.